Hi everybody, it's Miss B, and welcome back to another forensics video. Now, yesterday we talked about how to calculate that angle of impact, and you did 3 practice questions getting used to doing this. I know sometimes it takes you a minute to get back into SOHCAHTOA or calculating angles for triangles. So yesterday was some good practice for that and learning how a blood drop, as it splashes down onto a surface, is going to make a certain shape depending on that angle. And the way we can figure out what angle that blood hit is by calculating the inverse sine of a blood droplet's width divided by its length. Okay, so if you do need a refresher, feel free to watch yesterday's video back. Today, we are going to be adding on to this concept. So if you don't feel comfortable with this just yet, maybe rewatch the video, maybe redo those practice questions. And we are going to be learning a little something new today called determining the area of origin. Now this is where we are now going to be using those angles that we have calculated, and we're going to be lining them up to figure out where exactly that blood originated from, that area of origin. So this can tell us, once again, how high up that blood originally flew from, right? Imagine someone was hit with a bat and it made a wound that produced blood. We are now going to be able to tell where that bat connected with our victim, and we can figure that out using the blood spatter that is left from the wound. So in order to do this, the very first step is we have to find the lines of convergence. So say this is our crime scene and we have 3 blood droplets on the floor. Now, the very first thing is the line of convergence, which can help to pinpoint the location of a victim during the attack. The place where the lines meet is called the point of convergence. That's what I'm going to be calling it from now on. And this gives a 2D placement of the victim, also known as we now know where on the floor that incident occurred. Like, was it over here in the corner? Was it in the middle of the room? We now have an idea of where it happened in the room. We just don't know how high up. So 2D meaning one, like the 2 dimensions, so just on the floor. Okay, this is determined by the directionality of a blood stain. Now remember that the blood is always going in the direction of the tail. So this stain right here indicates that the blood was flying into this corner of the room. And this tail over here is telling us that the blood was flying over here to the right corner of the room. Now what I can do is I can actually draw lines through the middle of my blood stain, okay, from tail to the tip, and you're going to go the opposite way that the blood was flying. So if the blood was flying to the far right corner of the room, I'm going to be going inward once again. And where these lines converge is my point of convergence. Now this gives you the distance between my blood stain and the point of convergence where that incident occurred. So we know that the incident happened in the middle of the room, and now we can actually figure out how far away those blood droplets flew, how far away they were from that incident. However, what it doesn't tell us is how high up that blood flew from. Okay, so now we know where it happened in the room. However, I still don't know how high up it was. Now, this can give us a really good idea of the victim or the suspect's height, and just knowing where that blood spatter originated from. Did the blow happen very high up? Was it very low down to the ground? However, we can't figure this out quite yet. Right now, we just know where it happened in the room, but we don't know how high up it was. So now we have to do our next step, which is what you learned yesterday. Now we are going to calculate the angle of impact for our 3 bloodstains. Okay, so in order to do that, we are going to use the formula to find the angle at which each blood droplet hit the ground. Hopefully this is a little familiar, so we would go ahead and I would measure the width of my bloodstain and divide it by the length and multiply it by the inverse of sine in order to get that blood angle. So this is going to tell you the angle at which the blood hit the ground. And you'll notice that now I can add that in here. I have my angle, say maybe that's let's say a 35-degree angle. Okay, so I can draw that in. I can now do that for my other 3 as well. Now, if you'll notice that typically these 3 triangles are all going to have the same point or roughly in the same area. Now, this area where my points are all meeting is called the area of origin. Now I know exactly where that blood started flying from. So if, say, maybe this was at about waist height, right? It's about the height of the window. So maybe I know that this either happened and it was a blow to someone's abdomen, or I know that the person was crouching. This can give you an idea of what was happening in the room at the time. Now, we still don't know how high up that is per se. I don't have a number. And this is where the math comes into play once again. Now you'll notice that we now have triangles. So we're going to be doing a little bit of trigonometry again today to learn how I can figure out exactly how high up that incident occurred. Where exactly in the room in 3 dimensions did that incident occur and where did the blood originate from? Right? It's always good to be very specific, especially with science, and having those specific numbers to know where something exactly happened. So we're going to get rid of 2 of those triangles right now, and we're just going to focus on one of the bloodstains, one triangle. Okay, so in order to calculate the height at which this blood was sprayed from, we're going to be using the tan function. Now, you may remember this from SOHCAHTOA as TOA. If not, that's totally okay. But this is basically going to be using tan of our angle, and it's equal to the opposite length of our triangle divided by the adjacent side of our triangle. You may be wondering, okay, well, what's that? So we have our angle here, and remember that the opposite side is always opposite of our angle. So it's going to be, that's the length that we're looking for, right? We want to know how high that blood happened, so that is the length of our opposite side of our triangle. The longest side of our triangle is the hypotenuse, and that means that my one on the ground, the one telling me how far away my blood flew from the original incident, that is my adjacent side. Now, through talking through these notes for the past few minutes, we already have 2 of these numbers, right? Through the line of convergence, we can measure the adjacent side. So let's say that the adjacent side was 155 centimeters. So I know that there's a space of 155 centimeters between this point where the incident occurred and the very end of my blood spatter. And we also know my angle because I can calculate that using my sine function formula. So say this also happened at a 35-degree angle. These are two variables that we need, and now I can find my opposite side. So I'm going to fill in my numbers, right? So I have my angle right here, tan 35 is equal to x divided by 155 centimeters. Now we're trying to solve for x. We're trying to solve for the opposite side of our triangle. And so in order to do this, we want to get x on its own on one side of the equation. So in order to do that, we're going to have to get rid of the 155 centimeters. And the way we do that is we multiply both sides by 155. All right, so now these two here are going to cancel out. And I'm going to be left with this. X is equal to 155 multiplied by tan 35. Now, in order to do this, we are going to need a scientific calculator. So once again, go ahead and grab your scientific calculator if you have one. If you don't, that is totally fine, and you can follow me as we use the one on the internet. So I'm just going to go back to the Desmos website and use their scientific calculator. I'm going to go ahead and put in tan 35 and close my bracket, multiplied by 155 centimeters. And you'll see the answer right here. And we're going to just round that to the nearest decimal. So it's 108.5 centimeters. Perfect. So let's go back here. Perfect. So x is equal to 108.5 centimeters, also known as the height. So that means that the blood spatter's area of origin is located 108 centimeters above the point of convergence, which is right down here. Okay, so 108.5 centimeters above in the room, that is where our incident took place. Now you'll notice that we did this for only one of our triangles. However, I still have two more. Now, these are also very important and can give you very good and valuable information in your crime scene. We don't want to just use one triangle. We want to use all of them. We want to get as much data as we possibly can so we have a reliable answer. So for this, you usually want to calculate the angles and get the measurement for our opposite side of our triangle or our area of origin through multiple blood spatters. Now, not all of them are going to give you the exact same measurement, and that's okay. Say hypothetically, I were to do my tan formula for these two triangles and got a few different numbers. We're going to find the average, and this is going to give us the average height that that incident occurred at. So now we have a good idea and a very reliable idea of where that incident took place in the room. So say my area of origin for blood stain number 1 was, like we calculated, 108.5 centimeters. However, if we calculated the second triangle, maybe it gave me an area of origin of 110 centimeters. And our third triangle gave us an area origin of 109.8 centimeters. What you're going to do here is calculate the average. So we're going to add up the 3 area of origin calculations, and we're going to divide it by 3, the number of trials that we have. And this is going to give us our average value. So on average, if I were to use the calculations from these 3 blood stains, the average area of origin is 109.4 centimeters. All right. So I hope that this helps you and it helps you understand how you can figure out where an incident happened exactly in a room, not only by a 2D explanation, but also a 3D explanation. So once you've finished this video and you're feeling a little comfortable with our new tan calculation, please go ahead and finish the 3 practice questions that I have set up for today. If you have any questions, please feel free to watch over this video or email me. I'd be more than happy to help you out. I hope you're having a great day, everybody. Bye-bye.